Welcome back to my YouTube channel. Today we are going to see the State Board Science 2 for the class 10, chapter number 3, chemical reactions and equations. In this particular chapter we are going to learn about the chemical reactions, how actually the chemical reactions are taking place, different types of the chemical reactions, writing of the chemical reactions, balancing them, all we are going to learn in this particular chapter. So first of all, we should understand what exactly is a chemical reaction. Generally, when we talk about in nature, we have two types of changes, because to understand the chemical reaction changes of matter, that we should know clearly. Whenever we have the transformation of the particular matter from one to the another. So two types of the changes are possible in a matter. The one is a physical change and one is a chemical change. When we talk about the physical change is nothing but a change in a matter when there is a change in a size, shape, or the state of a matter. Like if we have a piece of a glass and unfortunately if it slips from your hand, it will fall down and the change will occur. The size of or the structure of that glass piece will change, because once it's slipping from your hand on the floor, it will break in a multiple pieces, and the size of every piece will be different. If you will compare it with the previous one, what was in your hand and what is now on the floor, the size will be totally different. The size changed, the structure changed. Or suppose if you are having a bowl and the water is kept on the gas stove in the bowl and you are heating it. After a few minutes, you will find that the all water evaporated, because that water which was in a liquid state will get converted into a steam or the gaseous state. So that is nothing but what the physical change. But if I'm talking about the other kind of changes, like if we are having a raw mango which is in a green color, if it ripes up after a few days, then it will get converted in a different color. From green will get converted into a yellowish color, and the taste also change. The raw mango which is sour in a taste will get converted into a sweet in a taste after ripening of a fruit. Same way the milk gets converted into a curd, the pickles we are storing, in that also we are using the different chemical to keep it for a longer time. Why? To avoid the chemical changes in that. So this kind of examples we have under the category of the physical and the chemical changes respectively. So let's see here that I have given a one table, some common phenomena they have given over here, which we can discuss whether they are physical or a chemical change. Like the first and the second one they have already given. The first they have given as a transformation of ice into water, which is nothing but the physical change that just now we have discussed. Then the next they have given as a cooking of food, which is nothing but the chemical change. Because the another thing which I missed in between, that is the when we talk about the chemical change, we cannot reverse the chemical change by any mean or the simple means. Physical change, by some way we can reverse it, but the chemical change we cannot reverse it by a simple means. Next, they have given as a ripening of fruit. So, ripening of fruit is nothing but the chemical change. Milk turned into curd is a chemical change. Evaporation of water is a nothing but physical change. Digestion of a food in the stomach is a chemical change. In the size reduction of a naphthalene balls exposed to air is a physical change, because here no new chemical bond is forming when the naphthalene ball is exposed to the air. Only the physical state of that gets converted into a gaseous state. Then afterward they have given as a staining of a shabadi or a kadapa tile by lemon juice is nothing but the chemical change. Breaking of glass object on falling from a height is nothing but the physical change. Now From here we can draw out that the physical change, we can reverse them by some simple means, but when it comes to the chemical changes, we cannot change them, we cannot reverse them. Further, they have given us an activity over here in which they have taken the zinc dust into the copper sulfate solution, and after adding the potassium chromate solution to barium sulfate solution, add sodium carbonate solution to the calcium chloride solution. Different chemical reactions they have given over here, and that all we are supposed to observe. Complete the following observation table with the references of the activities 1 to 5. So this is a practical part which we can see once the school reopens, and then in the laboratory we can observe this kind of changes. Now, the next important part is a chemical equation. Whenever this kind of a chemical reactions we are performing, we know the ingredients or the initial materials which we are using, the raw materials which we are using in the chemical reactions, which we call as a reactants, the initial raw material. Now, these chemical equations, they have a one specific way of writing. Like here, if I want to write down the chemical reaction, then the left side I have to write reactants. I have to write a reactants and then the arrow sign, and on the right side I have to write products. Why I'm writing the plural form as a reactants and the products? Because there may be a more than one reactant. That's why I've written as a reactants. In the similar way, one or more than one product can be formed. So always keep in mind this arrow mark indicates that on the left side we are having a reactant, on the right side we are having the products. This is a basic concept of writing the reactants and products. And whenever we have a multiple reactants or the multiple products, we are writing them with a addition sign. Now here the further part is they have taken the example of some chemical reaction like a aqueous solution of a copper sulfate plus zinc dust gives us an aqueous solution of zinc sulfate and copper. And this particular way of writing is nothing but in a theoretical or a statement way with the name of a chemicals we are writing. But if I want to write down in an equation form, this is a word equation, this is called as a word equation. And if I want to write down in a chemical formula, it's called as a chemical reaction. Here you can see the copper sulfate plus zinc, it gives us the zinc sulfate and copper. Further is the representation of a chemical reaction is in a condensed form. When we talk about, we are supposed to write this all in a chemical formula. We have to write this all in a chemical formula. Means whatever chemical compounds we are using, that all we have to write into a equation form. Further is writing a chemical equation. How to write the chemical equation? Because learning a chemical equation is a simple thing, but how to write that, that is also important. It should be a uniform to each and every one. So first of all, what they have given over here, the first statement is in a chemical equation, the reactants are written on the left hand side while the products on the right hand side. An arrow heading towards the product is drawn in between them. This arrow indicates the direction of the reaction. Second one, if the reactants or products are two or more, they are linked with a plus sign in between them. For example, in the equation 2, a plus sign is drawn in between the reactants copper sulfate and zinc. Similarly, a plus sign is drawn between the reactants zinc sulfate and copper. So this is the first two things which already I had explained to you how exactly we are supposed to write the chemical reactions. Now some more steps are there involved in writing the chemical equation. The third one, what they are saying, to make the chemical equations more informative, and the physical states of the reactants are also supposed to be written. And how to write, you can see over here, physical state like aqueous solution of copper sulfate. Then in that, for that we are writing the AQ in a short in a bracket as a subscript. Same way, the zinc was in a solid state, zinc sulfate in a aqueous solution, and the copper as a solid. So this we are writing the physical state. We are writing S for the solid, L for the liquid, and G for the gaseous. AQ we are writing for the aqueous solutions. After that, the any special condition required for some of the reaction, like if I want to write down the chemical reaction for the calcium carbonate. So when we heat that calcium carbonate, we get a quicklime and the CO2 gas is liberated. So that also we are supposed to write, like here this triangle sign indicate the heating. Some reactions requires the specific temperature, so that temperature also we have to write. Some require some extra inclusion of the catalyst or the some other chemicals to carry out the chemical reaction, so that also supposed to be written. Along with that, here you can see the one arrow sign. This arrow sign indicates that the liberation of the carbon dioxide gas. So if gas is evolved, we are showing it with the upward direction arrow. If suppose there is a some precipitate, then we are writing the downward arrow. The downward arrow indicates that the precipitate or the some solid formation is taking place which settles down in the chemical reaction. Further is, next is, it is necessary to fulfill certain conditions like specific temperature, pressure, catalyst, that all already I told to you, etc., to bring about the some reactions. These conditions are indicated below or above the arrow. So like here they have given the example of a 60 degrees Celsius with a nickel as a catalyst required in this particular reaction. Without that, this reaction will not take place. Further, spatial information of the names of reactants or products are written below their formula. For example, copper on reaction with a concentrated nitric acid gives a reddish colored poisonous nitrogen dioxide gas. So that should be written properly, like here they have written as a concentrated HNO3 is required. Same way here dilute HNO3 is required when it's reacting with the copper. So this kind of a conditions should be mentioned properly in the chemical reactions. So today we are stopping here. In the next lecture we will see some more part of the chemical reactions and equations.